9. Combining quantifiers with negation. As noted at the end of the previous section, any formula can be prefixed by either a universal quantifier or an existential quantifier, just as any formula can be prefixed by negation, and the result is another formula. In the present section, we concentrate on the way in which negation interacts with quantifiers. Let us start with the following open formula. 1px it is perfect. Then let us quantify it both universally and existentially, as follows. 2xpx everything is such that it is perfect. 3xpx at least one thing is such that it is perfect. These can in turn be negated, yielding the following formulas. 4xpx it is not true that everything is such that it is perfect. 5xpx it is not true that at least one thing is such that it is perfect. Before considering more colloquial paraphrases of the above sentences, let us consider an alternative tack. Let us first negate px to obtain the following. 6px it is not true that it is perfect. The latter sentence may be paraphrases either of the following. It is not perfect, it is imperfect. Many adjectives have ready-made negations: happy, unhappy, friendly, unfriendly, possible, impossible. Most adjectives, however, do not have natural negations. On the other hand, we can always produce the negation of any adjective simply by prefixing non in front of the adjective. Now, let us take the negated formula px and quantify in the two ways, which yields the following. 7xpx everything is such that it is not true that it is perfect. Everything is such that it is not perfect. Everything is such that it is imperfect. 8xpx at least one thing is such that it is not true that it is perfect. At least one thing is such that it is not perfect. At least one thing is such that it is imperfect. Having written down all the simple formulas involving negation and quantifiers, let us now consider the idiomatic rendering of these sentences. First, to say everything is such that it is perfect is equivalent to saying everything has a certain property it is perfect. These two sentences are simply verbose ways of saying everything is perfect. Similarly, to say at least one thing is such that it is perfect, which is an alternative to there is at least one thing such that it is perfect, is equivalent to saying at least one thing has a certain property it is perfect. These two sentences are simply verbose ways of saying at least one thing is perfect. The latter sentence, in turn, can be thought of as one way of rendering precise the following. Something is perfect along similar lines. Recall the way that the negation operator works. The official form of negation involves prefixing "it is not true that" in front of the sentence in question. Thus, for example, one obtains the following. It is not true that it is perfect. Recall that this is equivalent to the following more colloquial expression. It is not perfect. The advantage of the verbose forms of negation and quantification is grammatical generality. We can always produce the official negation or quantification of a sentence, but we cannot always easily produce the colloquial negation or quantification. For example, consider the following. Everything is such that it is not true that it is perfect, which is equivalent to everything is such that it is not perfect. Following the above line of reasoning concerning colloquial quantification, the natural paraphrase of this is the following. Everything is not perfect. Unfortunately, the placement of not in the sentence makes it unclear whether it modifies is or perfect. Accordingly, this sentence is ambiguous in meaning between the following pair of sentences. Everything isn't perfect, that is, not everything is perfect, everything is non-perfect. These are not equivalent. If some things are perfect and some things are not, the first is true, but the second is false. The original sentence, everything is such that it is not perfect, says that everything has the property of being non-perfect imperfect, or everything is non-perfect imperfect. To say that everything is non-perfect imperfect is equivalent to saying nothing is perfect, which is much stronger than not everything is perfect. The latter sentence is a colloquial paraphrase of it is not true that everything is perfect, which is a colloquial paraphrase of it is not true that everything is such that it is perfect. This is precisely formula 4 above. Now, if not everything is perfect, then there is at least one thing that isn't perfect, and conversely. To say the latter, we write at least one thing is such that it is not perfect, which is formula 8 above. Finally, consider formula 5xpx. It is not true that at least one thing is such that it is perfect, which is equivalent to it is not true that at least one thing is perfect. The number of things that are perfect is either 0, 1, 2, 3, etc. To say that at least one thing is perfect is to say that the number of perfect things is at least 1, that is, the number is not 0. To say that this is not true is to say that the number of perfect things is 0, which is to say nothing is perfect. Thus, we basically have 6 colloquial sentences. C1 everything is perfect. C2 something is perfect, that is, at least one thing is perfect. C3 everything is imperfect. C4 something is imperfect. C5 not everything is perfect. C6 nothing is perfect. These correspond to the following formulas of predicate logic. f1 xpx f2 xpx f3 xpx f4 xpx f5 xpx f6 xpx. As noted earlier, two pairs of formulas are equivalent. In particular, xpx everything is imperfect is equivalent to xpx nothing is perfect, and xpx something is imperfect is equivalent to xpx not everything is perfect. These are instances of two very general equivalences, which may be stated as follows. X equal X, X equal X. What this means is that for any formula A, however complex, we have the following. XA is equivalent to XA. XA is equivalent to XA. In order to understand them better, it might be worthwhile to compare these two equivalences with their counterparts in sentential logic. De Morgan's laws. In their simplest form, these laws of logic are stated as follows. dm1a and b is equivalent to ab. dm2ab is equivalent to a and b. But there are more general forms as well, given as follows. m1a1 and a2 and n is equivalent to a1a2, and m2a1a2, and is equivalent to a1 and a2 and in each other words, the negation of any conjunction, however long, is equivalent to a corresponding disjunction of negations, and similarly, the negation of any disjunction, however long, is equivalent to a corresponding conjunction of negations. But what does this have to do with universal and existential quantifiers? Well, imagine for a moment there are exactly two things in the universe, call them A and B, respectively. In such a universe, which is very small, every universally quantified statement is equivalent to a conjunction, and every existentially quantified statement is equivalent to a disjunction. In particular, we have the following. Everything is F. A is F, and B is F. Something is F. A is F, and or B is F or, in formulas XFX flaw and FBXFX flaw FB. Similarly, if there are exactly three things in the universe A, B, C, then we have the following equivalences. Everything is F. A is F, and B is F, and C is F. Something is F. A is F, and or B is F, and or C is F or, in formulas XFX flaw and FB and FCXFX flaw FBFC. This can be generalized to any finite number of things in the universe. For every universally/existentially quantified statement, there is a corresponding conjunction/disjunction of suitable length. Having seen what the equivalence looks like in general, let us concentrate on the simplest non-trivial version, the universe with just two things A and B in it. Next, let us consider what happens when we combine quantifiers with negation. First, the simplest. Everything is not F. A is not F and B is not F. Something is not F. A is not F and or B is not F or, in formulas XFX flaw and FBXFX flaw FB. Negating the quantified statements yields not everything is F. Not A is F and B is F. Nothing is F. Not something is F. Not A is F and or B is F or, in formulas XFX flaw and FBXFX flaw FB. Finally, we obtain the following chain of equivalences. XFX flaw and FB flaw FBXFX XFX flaw FB flaw and FBXFX. The same procedure can be carried out with 3, or 4, or any number of individuals. Note in the previous example, the formula A is simple, being Fx. In general, A may be complex. For example, it might be the formula Fxgx. Then A is the negation of the entire formula, which is Fxgx. Notice that the parentheses are optional in the conditional, but not in its negation.